Hey guys, welcome back. This week we're talking about glassing planets, the most frightening and devastating tactic used by the Covenant. They use both orbital and atmospheric bombardment to turn the entire surface of a planet slowly into an obsidian glass-like substance. The sheer amount of energy required is immense on a scale that many probably don't, comprehend. But despite how devastating it is in Halo, is that actually something aliens could even do? Could anybody reasonably glass another planet? Well, that's exactly what we're talking about this week. If you're new to the channel, consider subscribing. If you're used to the channel, welcome back. Let's talk about it. How does the Covenant glass a planet exactly? For starters, let's just look at how they do it in the lore. There's two apparent methods that I see discussed both in the books as well as what we see in the game. The first is a low-level tactical strike. This is what we see in like Halo 3, ODST, and Reach. The ships are lower in atmosphere and they're striking targets more tactical in nature. Covenant forces are also on the ground, so this makes sense, right? They're trying to reduce the risk of fratricide, a friendly fire. If you look at Reach, for instance, the Covenant bring in a Ket-class battlecruiser to glass New Alexandria. UNSC forces and Covenant forces are still fighting in the city. The Covenant pull back, allowing the ship to hit dug-in UNSC positions that were attempting to escape. On the other hand, if you look in ODST, they begin glassing as a means to excavate where the portal to the Ark is located, and they start doing that while Covenant forces are still sweeping through New Mombasa. Now, another thing to consider in the expanded universe is like the datapads in Halo Reach, like a kind of a collectible item that adds background flare. In those datapads, it's assessed that it would take a single Ket-class battlecruiser 15 seconds to glass 1 acre of a planet's surface, and that's highly dependent on the material, the desert being much easier versus the ocean. Now, this kind of lines up with Halo Reach, where we see those very ships firing on New Alexandria, but not quite for 15 seconds. They seem to fire for closer to like 3 to 5. The thing though is, although it looked really bad and sustained, the buildings are left standing and Noble Team is able to escape. On the other hand, the second type of glassing that's mentioned in the lore but not necessarily called out in game is a pure orbital bombardment, using heavy ship weapons to lob like balls of plasma, and it's not a beam. And the way I understood this is it's separate from those like low altitude strikes, and it's much closer to what we see in the cinematics of Halo Reach. If you think back, there's massive explosions on the surface of the planet, much larger in scale than what we see in New Alexandria, leading me to believe that these are different and these are actually orbital strikes and not just glassing beams. So then you might be asking, is this practical for the Covenant? Well, exploring it from the lens of the games, yes and no. I found that glassing a planet seems to shift a whole lot depending on who the writer is and what they need out of it narratively wise. In the books in Expanded Universe, glassing a planet sometimes takes days, sometimes years. Reach itself appears totally glassed in the span of like a couple days if you go off the timeline in the fall of Reach. If you factor in Halo Reach's narrative, which is a good bit longer, 3 weeks or so, it still appears completely destroyed when you see it in introduction, obviously, for Halo 2 Anniversary in the flashback. In the cutscenes of Reach itself, there's times where the surface impacts are absolutely bonkers. I'm talking about shockwaves glowing with energy hundreds of miles across. Whereas there's also portions like in New Alexandria, where 3 different ships firing in the same city as you, and it doesn't really impact both your aircraft or later when you're hiding. Because Noble Team, they survived. Understandably, they were in a shelter when it happened, but survived nonetheless they did. Many of the buildings are still intact and the air still seems safe to breathe by the time they get out. But then you kind of juxtapose that again with what we see at the end of Halo Reach that shows the planet's surface broken and cracked, glass-like, heat radiating from the surface. And it's kind of like difficult to kind of comprehend the two. Like in one, Noble Team was able to survive a very close in impact, and then the other, the entire planet's destroyed a week later. And that's what I mean. Some of it to me feels like it's driven by both like narrative as well as artistic flair. And at the end of the day, that's fine. It's a video game rights. I don't hold that against Bungie. But as with the heart of the channel, let's try and understand this from a reasonably accurate perspective. Bear with me, it's going to take a lot of assumptions, but let's work through the energy scales being discussed and what would be required. Right off the bat, the way that glassing is described in Halo may not be true to the numbers and ideas they use, but it will be doable if you adjust how you define it. And let me explain. We don't have a lot of data points to work with to understand what energy is required to glass. They don't talk about the energy contained in or distributed via a glassing beam. The closest thing we have are those data pads in Halo Reach that says it would take 30.5 years to glass Earth, or 1 acre and 15 seconds to glass again an acre. Silicon dioxide, aka silica, sand, that melts at 1610 degrees Celsius. So if we took 1 acre, 15 seconds, 1610 degrees Celsius. That's not even accounting for, the heat energy rather required to go through the phase transition from solid to liquid. Well, that would take 2.4 terajoules total. That's a 15-second beam for 1 acre, which is, roughly 43,560 cubic feet to a depth of 1 foot. I did that to make the math easier. 2.4 terajoules. Is that a lot? Well, not really. If you think about our most powerful weapons, nuclear weapons, the smallest of which, the little boy, well, that released 63 terajoules itself. So you can see like the way that some of the expanded lore is discussing it, not really lining up. But let's go ahead and unanchor it. Let's no longer consider the 15 seconds for an acre true. Let's just think about it from the perspective of 30 years to glass Earth. The most powerful weapon we've ever made, the Tsar Bomba, a 50 megaton nuclear warhead developed by the Soviet Union, well, that was 210 petajoules. So roughly 1,000 times more energy than the numbers we were coming up with earlier for the Covenant beam. It sounds insane. Well, that's the thing. Melting sand is actually very easy. You could melt plenty of the sand on Earth, but it would still be habitable, especially for something like humanity that, despite not having significant numbers, could probably use technology to continue. Things like the fact that the oceans would still be plenty cool and the atmosphere itself wouldn't be that hot. Now, talking about that, to raise the atmosphere by 1 degree Celsius takes 2.2 zetajoules. So now we're talking about 2.2 million petajoules. And like I said, 210 petajoules is the Tsar Bomba. So you can see that's a lot more energy to just raise the atmosphere by 1 degree Celsius. When you start talking about oceans, let's say the Indian Ocean, the third largest, well, 1,000 zetajoules raises it by 1 degree Celsius. You can see there's a lot there that you're going to have, like a lot of ground you're going to have to cover if you truly want to destroy a planet. Hardy enough survivors of humanity, especially, from the UNSC, could probably shelter at the bottom of the ocean and survive a glassing of the planet if you didn't see it through all the way to the end. But knowing the Covenant and their religious, extremism, they probably do exactly want to do that. So let's go down the ladder. What's the next most powerful thing we can think of? All right, well, let's talk about the asteroid that, killed the dinosaurs that hit Earth, the Yucatan Peninsula, 66 million years ago. How much energy was in that? 420 zetajoules. Thanks for asking. So now you can see that's about half a degree Celsius of the Indian Ocean. If we wanted to try and understand then what it would take, let's not even talk about oceans. Let's just talk about glassing the surface, the visible surface. Not, ignoring the fact that 70% Earth is water. If we just wanted to glass what we could see, well, it would take, 1,610 degrees Celsius. We'd need 3,500 zetajoules, so almost 9 massive asteroid impacts to raise the atmosphere from an ambient of 10 degrees Celsius all the way up. This would effectively turn much of the surface, not accounting for things like altitude nor latitude, to a molten mess. Granted, most of our surface is things like topsoil, high carbon content, so I don't necessarily think it would turn to glass. It would more look like charcoal, but nonetheless not livable at all. But that wouldn't boil away the oceans. And like I said, you could just hide underneath them. Sure, the top of the oceans may be boiling because how hot the air is, but water particularly has a very low heat transfer coefficient, meaning that energy would not penetrate all the way down deep into it. No, if we wanted to straight up boil away the oceans and make Earth a crusty glass / carbon ball, well, that's going to take a lot more. Let's take the Pacific, the largest by volume. It would take 300 petajoules per second to boil away over 30 years. 300 petajoules, again, being roughly 33% larger than the Tsar Bomba. So if the Covenant wanted to truly glass Earth in the 30 years that the datapad said, well, they'd be releasing 1 Tsar Bomba per second. If you consider that 1 kiloton is roughly 4.2 terajoules, well, then you can kind of do some division and see that a fleet 300 ships strong, roughly like Thel Vadim's fleet, would need to deliver 250 kilotons of energy per second for 30 years to glass Earth. To put that into context, you might understand the WA-8 nuclear warhead on most of the United States missiles is a 475 kiloton design. Granted, it's a variable explosive force. So it would effectively be like a fleet of 150 to 300 ships dropping one of those every second for 30 years. And that doesn't even account for things like cooling into the mantle, nor does it account for heat energy radiated out to space. That's a lot, right? Well, yes, but it also makes a lot more sense. Then, if you step back and look at those cutscenes in Halo Reach, each of those Covenant glassing beams was releasing the destructive force of a half megaton nuclear warhead. And when you see them going off in the city with the shock waves and the flash of light, that almost seems reasonable. Overall, though, glassing, as I see it, is doable if you make some bold assumptions and you readjust how it's described in the expanded universe. Some of the numbers they use would make it impossible to truly glass a planet, but if you anchor it to some like other known alternatives like asteroids or nuclear warheads, you see how it can actually happen. It would just take a long time, and whether or not that's actually worth the effort to the Covenant, well, that's a different story entirely. I hope you guys enjoyed this week's episode. Be safe, take care, see y'all later.